So what if I told you that in Revit, you could have an electrical box with a cover that at the click of a button can be recessed or surface mount? Well, that's what we're going to cover in this video, so stick around. Let's get right into it. So if you've done much electrical design or even installation, you know that electrical is full of boxes. We have device boxes, back boxes, pull boxes, junction boxes, panels are boxes, switchboards, everything's a box, really. So in Revit, it is handy to have just a box family that can be converted into these other kinds of devices and boxes. And one nice thing to have also is a family that can be recess mounted, like out of the box type of devices, but at a click of a button would be nice to have it surface mounted. I'm working with a client that does a lot of light industrial manufacturing kind of work, and they use a lot of surface boxes. Now, in a plan view, it's not quite as important how it looks. It'll just look like a symbol, like these receptacles down here. It's just the same symbol, whether it's recessed or not. But in 3 dimensions, if you're trying to do some coordination or even present some kind of a 3D view on your drawings, it's nice to have that box actually be surface mounted on the wall. So that's what we're going to do today. We're going to show you how to build this universal box as a custom family. It's a fairly good starter project. It has some complexity because of the toggle between surface and recessed, but as we get into it, I think you'll understand how it works. So what we want to do is actually start a new family. So go to File, go to New, and go to Family. And when you go to create a family, you have to start with a family template. Revit comes with many different kinds of family templates, as you can see here. Things as specific as electrical equipment, ceiling or wall based. There's a lot of hosted. That's what wall based is, a hosted family that has to connect to a wall or a ceiling. Fire alarm, we have mechanical, all these different things. Well, what I want to start off with is a generic non-hosted family that I can put anywhere in my plan. So I'm going to start with generic model. I don't want wall based or any kind of based. Based means hosted. We want generic model. So let's just open this up. And it puts us into the family editor. You have your views on the left, kind of like a project. And then you also have a properties box, which I put on the right. It can be anywhere. And you have your ribbon that you can create different shapes and create lines. You can add connectors to these families because, as we know, MEP is all about the connectors. And then things like reference lines and planes and things like that. So what we're going to do is get started on this box. It's going to be a generic box, so it doesn't have a category. Now, remember, in Revit, the families are classified by their category. You have electrical fixtures, you have electrical equipment, you have lighting fixtures. And so there's different categories. You have data devices, fire alarm devices. We're going to create this as a generic box, so it does not have a category yet. This is going to be the basis that we use for other boxes. Once you have this box created, you can use it to build panels, pull boxes, all these different boxes we talked about. You can use this model to create that. So this is just a generic box with a cover. This view we're at right now is called the reference level. It is a top view. As if you think of like a plan view, we're looking down at the top of our device, and our device is going to sit right here where these lines cross. You can click on this, hit F2 to rename it, and I'm going to say top view. And then this 3D view, I actually want to call this 3D view. So since this is a top view, this here will be the vertical center line of our box. I'll do it with lines here just to show you. We're going to have the back of our box like this, and then the faceplate will be out here. And this will be the wall surface for a recessed box. Now, for a surface box, I want all of this stuff to move out to here so that this wall line is at the back of my box. So we're going to put some parameters and some dimensions and mechanics into this thing to let this pop back and forward. So that's an example of what we're going to do. Now, to do this, we want to draw some construction lines. We're going to be using a reference plane. So a plane is like a sheet of paper. It's actually, it goes on to infinity. So we're going to draw a flat plane, and we're going to make the boundaries of this back box that I drew in. So we need a left side and a right side, and we want those to be parallel. And then we want the back of the box. And I can just say create similar and draw the back of a box. These are just kind of my sketch lines. We want a face of the box. Typically when these families are created, The face of the box is this line right there that is the wall. It's always at the face. But we don't want it always at the wall. We want the face of our box to be adjustable. So we need another separate line that is the face of our box and where our cover plate will go. So again, let's create a face of the box. Now I'm going to draw it a little bit off, a little bit forward of this line. Now this line here, I can't select it because it's pinned. Let me undo that. This is called the center, front and back. Again, back of the box up here, front's down here. This is the center. We're going to treat that as the wall. So here's the front of our box. So we're going to get this drawn in and as an extrusion. Now I want to put some measurements on this. So I'm going to use this standard. This is a dimension. It's an aligned dimension. As you can see here, we can do angles and radial diameters, things like that. Aligned dimension. And I'm going to go from what I'm considering the front of the box to the back of the box. Now, just as a side note, you can actually click on these and name these or label these lines. So let's go ahead and just name this one, just as an example. We'll call this front of box. There. Now, this dimension right now is set. I can change it by moving these around. You can see that dimension changes. Or I can give this dimension a label so that I can create a parameter for this. I want to create this box so that I can change its dimensions to make any kind of box I want. So up here under label dimension, I'm going to label this dimension. And right now there's none to choose from. So I'm going to create a parameter for this label. And let's call this parameter box depth. Now type or instance. This is where you get into a big decision on parameters, whether they want to be built into the type of that family when you bring it into a model, or do I want to be able to change each instance, each location of that box? I want to be able to make it variable. For the purposes of this universal type of box, I'm going to set these up as instance. Now I can change this later as I create actual device boxes or pull boxes or things like that. I already know that it's a length type of data. Now I can group it under a name. So leaving it as dimension makes sense. So that's good there. So, okay. There it is, box depth. Now I can change this box depth. I can change it here, or I can go up to the blue little symbol, family types. Now this is where you see the list of all your parameters. And under dimensions, which we chose, here's that box depth. It says default, which is your clue that this is an instance parameter. The default may be 1'9", but that's just how it's going to come into your model. After it comes in, you can change it in the instance parameters over in the properties box. Now we also want a box width. So we'll do the same thing. We'll put a dimension either here or go up to here to the quick access dimension from here to here. We're going to do the same thing here. We're going to click on that, give it a new parameter name, box width, leave it as type under dimensions. We're good. Simple. Now, one thing about this is I want this box to be kind of centered on this line. So right now I can move these dimensions around and it's not centered. So the way to make this centered is to use another dimension up here. And this time we're going to dimension from the edge to the center line to the other edge. Click anywhere. Now, up here you can see this little EQ with a slash. We click on that and it makes these dimensions I just created equal, which in effect centers this box. So now if I move these dimensions, both of them move and it keeps it centered. Now we can actually draw an extrusion of this box. So we want it to turn into a 3D box. Well, how do we do that? Let's go over to create. And here's where we have our forms: extrusions, blends, revolves, different types, different shapes. There's even a thing called void forms where you can actually cut out a piece of your box. So let's just go to extrusions, and it puts us in kind of a sketch mode. Things kind of dim out and we get the check and the X up here. Here I'm in Revit 2025 and they put the depth up here. It used to be down here, but you can make the depth of the extrusion because I'm working in 2 dimensions. I'm working on the width and the height maybe of a rectangle. There's also a depth, a Z component into or out of the screen. So I can set that. Well, I'm not worried about that depth right now because I'm going to force that depth to be a certain depth with another reference plane, as you'll see when we get to the front view. So we have our tools, drawing tools. We can use lines or rectangles, circles. You can even use pick lines, where you pick lines to be the edge and then have to trim them. I'm going to use the rectangle because I'm just drawing a simple rectangle. This is a box. Now I want to go clear down to the face of my box. Now I can make these hit exactly, snap to these reference planes. And when I do that, it gives me the option now of locking my sketch to that skeleton of reference planes. So I will go ahead and lock that. That's very important. And then I'm done. Locking it allows this extrusion to move with these planes. These planes are what guides this extrusion. We don't dimension the extrusion itself, we dimension its reference planes. So let's take a look at this in 3D. What do we have? There we go. We made a box. I hope you're proud. So there's our box, and we can make it look a little different. We can get it shaded so it's nice and gray with a shadow, but that's essentially what we made is a box. Now let's look at the front view. It's already here. The front view, we will see a datum point called a reference level. In this case, this reference level would be the elevation above the floor. What do we want that height to be? Do we want that height to be to the bottom of the box, top of the box, center of the box? Well, this has implications to what kind of box it ends up being. Let's say, for example, it ends up being a panel board. A lot of panel boards, I like to have the dimension, vertical dimension, to the top of the panel. For a receptacle or a data outlet, I like it to be to the center. Let's say a box you have behind a wall-mounted light fixture, a sconce or something. Maybe you want that to be to the bottom of the fixture. So this has implications depending on what kind of box you make. So in reality, you may need to create 2 or 3 different universal boxes for whatever you're making. For this box, we're going to call this one a box for a device. We'll go to the center. So we need a bottom of box and a top of box reference plane. Go back to create, reference plane. We're going to do a bottom of box and a top of box. Again, we're looking at the front, the face of our box, and we need some dimension. We're going to go from the bottom to the top, click anywhere, and we're going to call this box height. And the rest of these are good, like before. Now, again, that shows up in dimensions here, and we can see here there's no default on height or width. So I failed to change these two instances, but that's easily remedied. If you do it wrong, you can just edit it. So click on box height, go down to the pencil here to edit, and simply change it to instance. There it is. Same with width. So even though you create these once and you do it wrong, you can change that. Now we also want this box to be centered on this reference level. Now we don't want the actual level itself. There's actually, if you tab, you can see there's a reference plane behind it. That's what we want to dimension to. This reference level is kind of in my way. So what I can do is I can move it. Simply move it out of the way. There. Now it's still there. It goes on to infinity logically. But now I can get to this reference plane, which is what I really want to be dimensioning to. I want to equalize this. I want to center it. So let's go back to our dimensions. And we take our 3, and I can do it over this side. Get the 3 of them. Hit the equal. There it is. We get this error. Constraints are not satisfied. And you'll run into these as you're doing family editing because there's a lot of particulars with how constraints work. And they mean by constraints like locked things, things attached to dimensions like that. So what constraints? And we have this, it kind of yellows out or oranges out this center one. What's happening is this center line is actually pinned or locked. And so it's trying to move it to make it equal. So let's cancel that. So what I need to do in this case is equalize this before I give it a box height. So let's get rid of this. So what I'm going to do is I'm going to make sure these are equal first before I apply my equals to it. So it doesn't try to move, as you can see this pin, it doesn't try to move that. Now I don't want to unpin it because I still want this center line to be at this reference level. But I do need to make sure that these are equal before I apply my dimensions. What you can do is you can click on that, and then I can get to this dimension itself and just type in 1 for 1 foot. I can get to this one and type in here 1 for 1 foot. Now these are equal. So now when I do it, it shouldn't give me an error because they are equal, there. So now I can apply my dimensions for the height. Now you may think, oh, I have to recreate this parameter. Well, I don't because it's already made. Now, instead of creating a new one, I can just go to the drop down and find it, box height right there. So now I want to tie this extrusion to these dimensions so that my box height is controlled by them. The way I can do that, I don't have to go back into sketch mode to do that. I can do it directly from the extrusion. So click on the extrusion. I want to align the top of this extrusion to this reference plane. So what I use is the Align tool. Up here under Modify, up here is called Align, AL is a shortcut. Align it. I want to go to there, from there, and lock it. I still have the Align tool. I want to go to here, from, and make sure I'm touching the extrusion. It'll tell you, extrusion, and lock it. Now my extrusion is attached to these reference planes. And as I change the dimension, it changes, as you can see. It's good to test your family frequently. Pretty much after every dimension, I like to test it. It's called flexing your family. You flex it, bend it, and to make sure that it's working. Otherwise, you'll end up towards the end and it's broken and you won't know which step broke it because you're too far into it. So here's our 3D view again. And as we can change dimensions, we're going to get it down to something more close to what we really want. 4-inch height, 2.5 inches. Make sure we say inches, not feet. 2.5 inches, just as placeholders. And there we go. That's what our box looks like. Let's go back to our top view. So here's our box, and it got moved away from here because it floats. This box is not tied to this wall line yet. So let's go ahead and get this thing down closer to where we want it. So now what I'd like to do is to get this box tied to this line that's going to become the wall line. So the way I'm going to do that is I'm going to control this dimension, the dimension between the face of the box and the wall. When it's recessed, I want this dimension between the two to be 0. And when it's surface mount, I want the dimension between the wall and this line to be the box depth. See how that works? So I just need to create some parameters in here that do that. So let's get a dimension between the face of the box and the wall. From here to here. And I'm going to name it just that. Let's name it face to wall. I'm doing this lowercase because I don't want this parameter to really be adjustable by the user. This is kind of in the background. It's kind of like a working parameter. So I'm making it kind of nondescript. I'm making it kind of blend in. Now, the way I can make it blend in is get it out of the dimension heading. I'm going to put it down in a place called Other. I'll show you where that ends up. So Other, again, we need instance. Look at the parameters now. You look at dimensions, you don't see it. It's way down here under Other. And when this family is in a project, in a model, there'll be other parameters in the way. This is going to be way down at the bottom. People are not even going to see this. We're also going to put a formula in here so that people cannot change this. So I'll show you how that works. So that's the first step. We have this dimension. How can we make this dimension variable? Well, we're going to give the user a button to push to change it from recessed to surface. I want the default to be recessed. It's like you see out of the box when you get a receptacle. And I want to give them a button. Now, how can I make a button or a switch? Well, the way you do that is to create a parameter that's called a yes/no parameter. Now, I don't need to tie it to a dimension. I just want to create a parameter from scratch. So in my family types, down here at the bottom, I can say new parameter. I can create a parameter from here. New parameter, same box. I'm going to call this surface, which means if you click the box named surface, it turns it into a surface mount box. It's also instance. Now, discipline common is fine. The data type, this is where I can pick what I want. The dimensions were lengths. You could be integers, angles, any kinds of data type. We want it to be a yes or no. And I do want this group somewhere where I can easily get to it. I don't want it down here in the bottom other. Do I want it under dimensions? Possibly. Another place I like to put it is someplace called graphics. That ends up kind of up top. And you'll see. So here, there. So graphics ends up here. It's kind of easy to find for the user. It says surface. It's checked right now. But I can check it or uncheck it. I'm going to make the default unchecked, which means it would be recessed. Now, follow along with me. This is where it gets a little complex as a starter family. we are going to use a formula, and we're going to use some Boolean logic. Okay. So what we're doing is we want to create an if statement. If you've done any coding or anything like that, you know how those work. An if statement to say, if the user selects surface, then I want this face to wall dimension to be the box depth. Remember we talked about that? We want to pull it out. We want it to be box depth away from the wall. If it's not selected, we want that face to wall distance to be 0. Those are our two conditions. So the way you do that in Revit, if, and then put in parentheses. What am I testing? I'm testing the variable called surface. So I just type it in. If surface, and that just means if surface is selected. Surface equals 1. If surface is asserted, whatever you want to call it. Surface is selected. If surface, it implies if yes, comma, what do I want to happen? The first thing I want to happen is I want face to wall to be box depth. So again, I just type that in, box. You don't get to select it or choose it. You just have to type it in exactly the way that the parameter is set up, box depth. Another comma, if not. So if then, and if not, or else, we're going to say it's 0. Simple. So the face to wall distance, if surface is checked, it's going to be the box depth. If it's not checked, it's just going to be 0. Into parentheses, apply it. If I didn't make any typos or spelling errors, it should be fine. Looks like we're good. Say, okay, I have it unchecked. The face to wall is 0 because surface is unchecked. Now, if I go to surface, I'm going to make this box a little smaller so we can see what's going on. Now, if I click surface and say apply, bam, the box jumped out to the face of the wall. So simple checkbox moves that to surface and recessed. Now I'm going to go ahead and keep it surface now to do the rest of the family. I would like to add a cover plate to this box. Most of the boxes you use will have some kind of cover plate. Now that varies too. In real life, a recessed box cover plate extends beyond the box. On a surface cover plate, that may be the same size as the box. So we can get crazy and apply some more dimensions for this cover plate width and overlap and all that. For the purposes of this family, I'm not going to do that. I'm just going to let it overhang for either case. So what we're going to do is create another extrusion. This is the cover plate. I need to create some more reference planes. So this will be the face of the cover plate. And then I also have sides to the cover plate where it extends over. I'm going to make the parameters be the extension so that if you want to get crazy and include some more adjustability features for this cover plate, we can. So let's do that. Dimension from here to here. And we're going to call that. Now, if these dimensions get in the way, you can move them out of the way down here. You can also get them smaller just by changing the scale of the family. Now, this doesn't change anything, no dimensions get changed. It's just a graphical representation. It just allows these dimensions to be smaller on the page. So we're going to make this dimension be something like cover overhang, something like that. That's how far the cover extends beyond the sides of the box. Again, we'll make these all instants. It's a dimension. So cover overhang. Now I want the other side, because I want this to be the same, the other side to be the same thing. Now I can't do an equals because I've got a gap between them, but I can just set it to the same parameter. So this guy here, when I go to set this dimension to a parameter, I can choose a parameter I already have, which is cover overhang. And that way they're both the same. You can use these parameters over and over. I'm also going to use that for the top and bottom overhang when I do the face view. One more thing I want to do in this top view is the depth of the cover. So here, from the face of the box to the face of the cover, and I'm going to call this cover depth, thickness, whatever you want to call it, or depth. So all these parameters are going to be available to the end user. So now we can create this extrusion, and then we'll go and do the front like we did the other. So we just need another extrusion, which is going to be this box here to be the cover plate. Create, extrusion, rectangle. Now this time I'm going to draw it a little bit over and show you how you can align these. Now we can use, I'm still in sketch mode. It's purple and or pink, and I still have these here. I can align this now. So align there, lock it, align to here, from here, lock it, to here, from here, lock it, and to here, from here, lock. We're all locked. Now it kicked me out of my sketch mode because I'm in the align mode. So I need to go back here. There we go. And finish that. Now my cover plate extrusion is aligned to its dimensions. Let's take a look at the front. Cover plate's huge because we don't have dimensions on the height yet. Let's go ahead and create similar. And let's get some height and some lower dimensions to this cover plate. I want the overhang to be the same. So here we go. Just putting these dimensions. Click on it, choose the overhang that I already have. Overlap, give it whatever descriptive word you like. Here to here. That's the bottom of the box. Overhang. There we go. Now I need to attach this extrusion to those dimensions. So let's do this bottom guy first. Let's align to here from this one and lock it. And the top of my cover plate, I want to go to here, from here. Now, you can see my cover plate expands nicely in all directions. Things are flexed. I have things set up as instance parameters. We're good there. So in 3D, this is how it looks. Now that's ridiculous because the cover plates, the dimensions aren't right, but you can see how that works. And again, I have my surface, apply it, pop it back for recessed. There we go. Now, I'll save this as my generic box. So I'm going to file save as, and it's a family. I'm going to save it as, and I like to put my descriptive initials there first. I'm going to call it universal box. Now, because of that dimensioning for the height, could be the bottom of the box, center of the box, top. I'm going to call this center. It'll remind me that this box is set up for the center as being the mounting height. I'll have another box. It'll be called bottom or top. Save it. Now this box is ready to be turned into other things. I'll want to add a symbol to this. I have other videos that show you how to add a receptacle symbol to this family so that the symbol shows up the same size in every scale. You may want to add some graphics, some lines to the face of this cover plate to look like a receptacle or a data jack, fire alarm pull station, whatever you want it to look like. This is now the basis for many, many other families that you will not have to recreate this box every time. Check out this video that I have on the screen now to find out how to make more custom families.